Hello guys, welcome back to my channel. So this is second part of naive Bayes, multinomial and Bernoulli model training. So in first part, what we have done, we have imported an data set and we have classified the sentences into two categories, whether it belongs to cinema or whether it belongs to education. Okay. So today we will go ahead and train our model based on that data set. So if you remember, in yesterday video we have done some basic data loading and cleaning of the data, and we have also learned about what is bag of words. Okay, so now let's go ahead and train our model. Okay, but before that, let's understand something about sparse matrix. Okay, so what is a sparse matrix? If you have learned it in mathematics, a sparse matrix is a special kind of matrix where most of the element is zero. Okay, so if you see my this matrix, you can see most of the element is zero, and assume that we are having a data set of 100 and thousand or million records. Then this will be a huge data. The memory it will take to store, it will be like quite huge because of these uh, zeros. Okay, and this zeros is something which we don't actually require. Okay, so what we will do, we will compress this matrix. Okay, so when you use count vectorizer, it by default compress your matrix in by removing all the zero. And how it does that, you can see here. So let's understand what is this saying. Okay, so we can see in our first sentence, so we will say 0 because indexing start from 0. So in our zeroth sentence, okay, the second word, indexing starts from 0, so 0 1 2. So second word occurs one time. Same information you can get here. 0 sentence, second word occurs one time. Okay, same if you see in the fourth sentence, 0 1 2 3 4, fourth word occurs two times. So here you can also see in fourth sentence, fourth word occurs two times. Okay, so this is how we have removed all the unwanted zeros in this matrix, and now this matrix looks too cleaner, and it will also take very less space compared to this sparse matrix. Okay, so it's a good idea whenever you train your model, always use compressed matrix. Cool. Now let's go ahead and train our model. So as we have prepared our train data, let's split our test data also. So same thing we will do by using our test data. Okay, we have converted our train data also, now convert our test data also, and we will create the matrix. Okay, now let's how the data looks like. Okay, now first we will use the multinomial technique. Okay, so what is the difference between multinomial and Bernoulli? So multinomial focuses on the occurrence of the number of the occurrence. You can say it as frequency, the frequency of the word, whereas Bernoulli were only concerned about whether the word is occurring in the sentence or not. Okay, multinomial, as the name is suggest, can have multiple outputs and can have multiple outcomes. Okay, but in Bernoulli we can only have binary output. It means two outcome is possible, suppose spam or ham. Okay, that kind of thing. So let's first train our model in multinomial device. So for that we will import our model using sklearn naive Bayes multinomial. We have created an object and it's pretty straightforward. We have just called the fit method. So till now we have used this method many times. So when we train any model, we use this fit function. Okay, so we are passing our train data here, so x train and y train. Okay, next what we are doing, we are calculating the probability in probability variable. Okay, so let's go ahead and we are calculating the probability of the test data here, and we are printing that. Okay, so here you can see the probability of the sentence of being education is 67, which is larger than the probability of the cinema. So it simply means the sentence belong to education. So if you see our test data, you can see the class is 1. It means our sentence actually belongs to education. Correct? So that means the prediction from the model is like accurate and it's acceptable. Okay, now let's go ahead and build the same model using Bernoulli net bias. So all the process will be same, only thing will change is this Bernoulli, we will use this Bernoulli classifier. Okay, and we have created the object, same we have fitted the data, and we have done the probability prediction of the test data. Okay, and you can see the value is slightly changed from the multinomial. The results are slightly good as compared to this. Okay, so here you can also see the probability of being it in education is higher. So it means, it simply means our sentence belong to education data. Okay, so we will end this video here. Let's go back and revise all the things, do some your calculation, calculate the confusion matrix and all the things using, do some matrix evolution by your own, as we have didn't done it here. And in next video I will take a real time data so of SMS to predict whether the SMS is spam or ham based on the contents in the SMS. Okay, till then, bye bye, thank you.